This presentation will introduce concepts related to testing for goodness of fit. Note that this presentation is not meant to replace your reading of section 6.3 in the textbook. While watching this presentation, it would be very helpful if you follow along in the corresponding portions of the textbook. Lastly, please note that you are responsible for reproducing all parts of this presentation on paper according to our course guidelines for formatting of written work except for any portions that appear in italics, which will start on the next slide, or any slides within the presentation that are specifically identified as not requiring reproduction. So keep in mind that this video is going to develop a method for assessing a null model when the data are binned. We will illustrate this technique for a sample of cases that can be classified or binned into several groups to determine if the sample is representative of the general population. The technique will introduce a new statistical test known as the chi-square test. I'm going to use the exact same example provided in section 6.3 as our goodness of fit example. Please take a moment to read the information on the slide, pause the video while you do so, and then come on back and we'll proceed forward from here. Hopefully you've taken some time to read through the example problem statement. Note that we are going to use the exact same four-step process for implementing a hypothesis test as we have been using up to this point in the course. So the four steps for that are prepare, check, calculate, and conclude. Note that in this case, though, for calculate, there is no sketch that will need to be drawn as we have been doing up to this point in time in the course. So the first step of our four-step process is the prepare step. We're going to create a table of observed and expected counts for the groups or bins, list hypotheses, and identify the significance level. Fortunately, we already have the observed counts in the form of the representation in juries row of the given table. So next we're going to move on to finding the corresponding expected counts, and to do so we're going to use our guru to enter the observed counts and population proportion values from the table for each race. So within our guru, I left-click on Analytics, left-click on Analysis, come down and left-click on Goodness of Fit. That will bring up a dialog box that we can enter our data into. I want to go ahead and enter the data directly. So I'm going to come down to this plus sign, left-click on that 4 times to give myself 4 rows in this particular data entry. Double-click on the label here. The first label I'm going to put in is for the racial group being white. So white, I tab to go over to the observed count. This will be the number of jurors from this county that were in the random sample and are white. So there were 205. And then the next null probability is going to be the percentage of registered voters in that county, which we saw from the table in our problem statement was 72% or 72 hundredths. I then go ahead and tab over to label 2. This one will be for black jurors, of which there were 26 in this county in the random sample. Oh my goodness, can't type a 6 in, there we go. And then there are a percentage of 7% of the county that are black in this case. So I put that in as my percentage. Next we have Hispanic. And then there were 25 jurors that were Hispanic in the sample. And then there are 12% or 12 hundredths of the county that are Hispanic. And then next we put in other. And in this case, we have 19 jurors that were other, and 9% of those were comprised the racial groups in that particular county. Okay, that's it. Now I come down here under test, left click on that to select chi-square, uncheck the graph box. Significance level is at 5%. We're going to leave that as is because we were not told the significance level, so it's always assumed to be 5% otherwise. And let's preview that. Okay, and here we see the information provided for the expected counts that we will use for constructing our table of observed counts and expected counts in our written work for this problem under the prepare step. So I want to close our time looking at how to use our guru to perform a goodness of fit test by pointing out that this is called the data summary and diagnostics table that I'm going to get the expected counts from, and then later in the presentation I will refer to the chi-square goodness of fit test table, which shows the observed test statistic, the chi-square value, degrees of freedom, and the p or probability value that I will refer to later on in the presentation. Okay, now that we've seen how to use our guru for a goodness of fit test, note that we would put the following work on our paper. If we were performing such a test, I would write, using the arguru goodness of fit test function, we entered the observed counts and population proportion values using the problem statement table. Expected counts were then generated as part of the goodness of fit test as a data summary and diagnostics table, and then I would show the observed data and expected counts table for this prepare step. Quick comment, and again, you don't need to copy this slide in your notes. The sample proportion represented from each race among the 275 jurors is not a precise match for any ethnic group. While some sampling variation is expected, we would expect the sample proportions to be fairly similar to the population proportions if there is no bias on selecting juries. We need to test whether the differences are strong enough to provide convincing evidence that the jurors are not a random sample. So the ideas on the prior slide can be organized into some hypotheses, and here they are listed on the slide. First, we have our null hypothesis, which says that the jurors are indeed a random sample. That is, that there's no racial bias in who serves on a jury, and the observed counts represent a natural sampling fluctuation. You wouldn't need to write the IE if you were doing this on paper. I'm just providing that as an explanation for this null hypothesis. The alternative hypothesis would be that the jurors are not randomly selected. And of course, that would mean that there is racial bias in the juror selection. Closing out the prepare step, we also note that throughout this example, we're assuming a significance level of 5% since that was not stated beforehand. Let me close with one more quick comment that you do not need to put on your notes. To evaluate the hypotheses on the previous slide, we quantify how different the observed counts are from the expected counts. To do so, we use a new test statistic known as the chi-square test statistic. Note that you can learn more about the definition of the chi-square test statistic and how it's calculated in section 6.3.2 of the textbook. Also, you can learn about the chi-square distribution and finding tail areas for a particular chi-square value in section 6.3.3 of the textbook. Now, because we are using our guru to find chi-squared values and their corresponding tail areas, we will not discuss the above portions of the textbook in this course. We now move on to the second step in our four-step process, namely the check step. We must verify the two conditions for performing a chi-squared test. So the first one is very familiar to us. It's the independence condition check. Each case that contributes to a count to the table must be independent of all the other cases in the table. Well, in our case, we can certainly assume that each juror is categorized as only one of the four race groups, and therefore the independence condition is met. The second condition is the sample size or distribution condition. Each particular scenario, that is, cell count, must have at least 5 expected cases. Well, when we take a look at the table that we created as part of our prepare step and we look at the expected counts, we see that they are all much greater than or equal to 5. And so therefore, the sample size distribution condition is easily satisfied in this case. We now move on to the third or calculate step of our four-step process. We see that if the conditions hold, which we saw was true in the check step, we then identify the degrees of freedom, compute the test statistic, and identify the p or probability value. The degrees of freedom is simply one less than the number of bins or groups, which in our case, we saw that there are 4 different races or bins or groups, so the degrees of freedom is 3. The information that I now show below was generated as part of the arguru goodness of fit test as a chi-squared goodness of fit test table. So you would need to write that sentence on your paper as part of the work for then providing the chi-squared test statistic value rounded to 2 decimal places, just like we do with z-scores, and then the p or probability value rounded to 4 decimal places. And again, remember that we saw that when I did the arguru portion of this presentation. We now move on to the fourth and final step of our four-step process, the conclude portion. We need to evaluate the hypothesis test by comparing the p or probability value to alpha, the level of significance, and provide a conclusion in the context of the problem. So let's look at the evaluate step first. Because the p or probability value is greater than alpha, that is to say that 1,171 10,000ths is greater than 500ths, we fail to reject the null hypothesis. Therefore, in conclusion, we can state that the data do not provide convincing evidence of racial bias in juror selection. And that concludes this presentation.